expansion. Now we have example number 2. And we have here y double prime plus y is equals to 0. So we have the generic form of the power series y summation where n is equals to 0 c sub n x raised to n. Deriving that, we will have the y prime summation where n is equals to 1, and deriving this equation, we will have nc sub n x raised to n minus 1. And further, we will have y double prime deriving this part, the summation n is equals to 2, n multiply n minus 1 c sub n x raised to n minus 2. So following this, we have in our problem y double prime and y. So we will substitute that in the form of the equation. So y double prime is equals to n minus 1 c sub n x minus 2 plus y equals to 0, c sub n x raised to n is equals to 0. And now, as we notice, we have an unbalanced summation sign, which in the index of the first part is n is equals to 2, while here we have n is equals to 0. We could actually balance that out by subtracting 2 in here, so it will result in n is equals to 0, and balancing that, we should add 2 in this whole equation. So we will do that. So resulting, we have 2 minus 2 is equals to 0, and then n plus 2, n minus 1 plus 2 is n plus 1, c sub n plus 2 x raised to n. Because n minus 2 plus 2 is equals to 0. So plus summation 0c and x raised to n is equals to 0. So we now have a balanced summation sign. Also, our x raised to n variables are now equal. So we could factor them out. And now the whole equation will be n plus 2, m plus 1, cn plus 2, cn plus 2, plus cn, factoring out x raised to n equals to 0. So now we can now perform the recurrence relation of this differential function, where x raised to n is not equal to 0. So we will write that as n plus 2, n plus 1, c sub n plus 2 plus cn is equals to 0. We are going to find the coefficients by the largest index, or the high index, n plus 2. So we will equate everything. So c sub n plus 2, so we will transpose c sub n over the other side to have a negative c sub n, and then divide that to the other side, n plus 2, n plus 1. So this is our recurrence relation. So now we could substitute n values in determining the series expansion. So first we have n is equals to 0. So it will be so we have c sub 2 is equals to negative c sub 0 over 2 multiply 1. At n is equals to 1, we will have c sub 3 negative c sub 1 over 5. We have 3 multiply 2 at n is equals to 2, we will have c sub 4 negative c sub 2 over 4 multiply 3. But also we already have c sub 2. Take a look at that. So c sub 2 in here, c sub 2 in here. We will just continue. N is equals to 3. We'll have c sub 5 equals to negative c sub 3 over 5 multiply 4. So, as you can see, we already have c sub 3 in here. So we can derive that. Now, we have the equation y summation equals to 0. C sub n is x raised to n equivalent to c sub 0 plus c1x plus c2x squared and c sub 3x cubed plus goes on and goes on. Now we could insert the coefficients into this equation. Continuing the process, we could actually evaluate this now. So c sub 2 is equals to negative co over 2 multiply 1. So c4 could actually be positive c1 over the factorial of 4. And c5, c sub 5, now equivalent to positive c1 over factorial of 5. C sub 4 is 0. There you go. And then we could, for the even coefficients, we have negative, by analysis, we have negative 1 raised to n. So for even, we'll start to 2, so it will make the negative 1 positive. C sub 0 over 2n factorial. And for odd coefficient, we have negative 1 raised to n, c sub 1 over 2n plus 1 factorial. So we can apply that now. Having this recurrence relation and rearranging all of the coefficients into this equation, we will have y function of x is equals to c sub o, c sub 0, 1 minus c 1/2 1 over 2 factorial x squared plus 1 over 4 factorial x raised to 4 and go down plus c1 is multiplied to x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x raised to 5. And we can now see that this whole equation, this series expansion, is equivalent to y. You can notice this is the series expansion of the cosine x, and this is the expansion of the sine x. So c sub 0 inside the c sub 0 is the cosine x function plus c sub 1. Side here is the sine x function. So now this is a transcendental function of the power series expansion y double prime plus y is equals to 0.